Hi, welcome to my channel, JaberTime. We're going to go over the expected value, and this is going to be part 1. So there's more videos coming, at least part 2 is coming, with more examples. Let's get started. The expected value. The amount you would expect to win or lose per game after playing a game of a chance many times is called the expected value. For example, the $9 right here portion of the spinner at right makes up 30 degrees out of 360 degrees. This is only 30 degrees. The whole circle, the revolution is 360 degrees. So this becomes 30 over 360, which is about 1 over 12. So if you make all the slices right there equal to 1 over 12, this will contribute or cover 11 pieces, slices, and this will cover only 1. While the 4 portion is the rest, which is 330 divided by 360, and that's 11 out of 12. So keep in mind, this is a small one, 1 out of 12, and this is the 4 will be 11 out of 12. Therefore, someone spinning 12 times would expect to receive 1 9 and 11 4s, which makes sense, right? If it lands on every slice once, and I have 12 total, the 4 will happen 11 times and the 9 will occur 1 time. So if you do it 12 times, you're going to get $53. That is kind of like the main concept of the expected value. So if you play 12 times, you're going to get $53. And on average, each spin would earn an expected value of 53 divided by 12. It's about $4.42 per spin. This is called the expected value. Now that's not going to happen because you're not going to collect $4.50 or $7.25. We're collecting $4 and $9. But on average, it's like per game, per 1 time you spin the spinner, you're going to get $4.42. Now, you could use this value to predict the result for any number of spins. Like you want to spin it not 12 times, you want to spin it 15 times, 100 times, and so on. For example, if you spin the spinner 30 times, you would expect to win 30 times 4.42, about $132.50. So it is useful to find the average per once. This way, if you want to do it not evenly like 12 and multiples of 12, you could expect or know what to expect. How about 24? Well, that makes sense to see it without too much math. 24 is 2 times 12. 24 times 4.42 will be 106.08. Let's do it differently. Notice that 24 times, you would expect 22 times the 4 and 2 times the 9 because you're doubling the 12. So 9 will be twice, and 4 that was discussed to show up 11 times is going to show up 22 times. So 22 times 4 plus 2 times 9, which is 106. But because here we're using the average, we have a decimal form. On average per spin, 106 divided by 24, it's 4.42. Now, another way, we're still in the same problem. Another way to calculate the expected value involves the probability of each possible outcome. This has a probability higher than the 9, so it's going to show up more. It's going to affect your answer as an average more. Let me show you how. Since $9 is expected 1 out of 12 of the time, and $4 is expected 11 out of 12 of the time, then the expected value can be calculated with the expression as follows. The expected value of the event X equals the sum of each event or result, like xi, which is 9, and x1 and x2 will be 4, times the probability. Well, if this is abstract, let's see it in writing with our numbers. Here we go. This is the sum of x1, $9 as a result, times its probability, which is 1 out of 12, plus x2, the second outcome, times its probability, which is 11 out of 12. Do the math. I get 53 out of 12. Divide, you get 4.42. So if you wanna skip the first slides and do the common sense idea, you could always believe in this formula, and that will give you the average per one spin. Now, a fair game is one in which the expected value is 0. The reason why I call this video part 1, because it's kind of hard to cover everything about the expected value in one video. For example, I don't have examples here about the fair game, and how do you make a fair game if it's not a fair game, and so on. So that's coming in the second video. A fair game is one in which the expected value is 0. Neither player expects to win or lose in the long run. So imagine if you're flipping a coin, heads and tails, and if you win, you collect $1, and if you lose, you pay $1. If you play for 8 hours, you might go home with the same money that you started with, right? Because it's kind of like, it feels like it's even. You win as many times as you lose as many times, and you gain or collect $1 as you give away $1 as a sum, I mean. So end of the day, it's like you're playing for fun only. We're gonna have some examples of the second video. Here's an example. Consider the following game. After you spin the wheel at the right, you win the amount spun. So if it lands on 4, you collect $4. If it lands on 0, you collect $0. In other words, you don't make any money. If you play the game 2 times, just to give you the concept and believing in your answers, how much money would you expect to win? Well, I picked on 2 times because the spinner is divided evenly into 2 sections. And I believe it could land once on 0 and once on 4. So you end up collecting 0 plus 4, or you collect just 4. So you want to keep this in mind. Every 2 spins will give you $4. And the story continues from there. Every 2 spins will give you $4. How about if I do it not 2 spins, 4 spins? That will give me what? $8. If I'm doubling the 2 times to 4 times, the $4 becomes $8, right? How about 8 times? 8 times will be 2 and 2 and 2 and 2, right? And every time at 2 times I spin the spinner, I'm gonna get $4. So the answer should be 16. If you take your time to understand that it's all about every 2 spins will give you $4. 10 spins, 10 times will give you $20. 30 times will give you $60. 100 times will give you $200. And I think we see the concept. It's like 4 gives you 8, 8 gives you 16, 10 gives you 20. So it's like times 2, right? That's the idea right there. So what if you played the game n times? We're gonna generalize it now. You win $2 times n. So if n is 4, 2 times 4 is $8. If you were to play only once, what do you expect? 2 times 1, $2. Well, if you think about it, if you play once, you're gonna either land on 0 or 4. But if you play twice, you're gonna land on 0 once and at 4 once. So you make $4 in 2 spins. Per 1 spin, it's like on average you make $2. And that's what you wanna take with you. So is it actually possible to win that amount, $2? Of course not. There is no $2 in the game. Either $4 or 0. Either $4 or 0. No, it is not possible to win the $2. This is because the mathematical expectation is an average winning value per game, not an actual one. You want to keep this in mind. Now, here's another spinner. This spinner has 3 sections. They're not all equally likely. So as you can see, we're building up more and more examples. Let's see what happens with this game. How much would you expect to win after 4 times? 100 times. Notice that they are not saying 3 times. It's 4 times. They're thinking about this as 4 sections. Imagine if there is a line right there. That means a 0 here and a 0 here. 2 sections out of 4 will give you $0. Because that acts like 2 sections. That's why we're saying 4 times. 1, 2, 3, 4. In 4 times, you're going to get $4. And you're going to get $100. And you're going to get $0 twice. That's 104. Hopefully that makes sense. So every 4 times you make 104. In 100 times, well, 100 times compared to 4 times, because every 4 times will give you 104, and 100 times is 25 times 4 times, right? So you're repeating this game 25 times to make it 100. But every game, if you call it a package game, every 4 times will give you 104, and I'm doing the 4 times 25 times. That's 25 times 4. So it's 25 times 104, which is $2,600. Find the spinner's expected value. That is, what is the expected amount you will win for each spin as once, like on average. For every 4 spins, you will make 104. Divide by 4, you get $26. There is no $26 in the game, as you could see, but that's called on average. So we use it for predictions for like 5 times, 7 times, and so on. Or we could say the following. I'm using the formula now. 1/2, that's 1/2 times 0, plus 1/4 times 4, plus 1/4 times 100. Every section, every event times its probability. $4 times its probability, which is 1/4. $100 times its probability, which is 1/4. Do the math. You could write 1/4 times 0 plus 1/4 times 0 instead of 1/2 times 0. Thinking about that, this is 2 zeros right there. And I could see I'm pointing to the sections as we have 4 equal slices or sections. 0 and 0 and 4 and 4, 100 I mean. Times 1/4 times 1/4 times 1/4 times 1/4. Do the math, it's also $26. That should do it for this video. It's about 15 minutes or less. And in a week or so, I'll make another video called Expected Value Part 2. So we could talk about the fair games and more examples. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.